Now, the key word on this, and again, this is all directly aligned with what's going to be on our test, okay? So if I'm saying something, it's important. It's something you have to know, something you have to keep in mind if you want to do well on the test. Another reminder, because we're taking the test on the last day of the term, you cannot do test corrections. So the score you get is the score you get, and what it does to your overall grade in the class is final. So it's extremely important. We have to be as prepared as possible. That's why we're going over this focused review. So the key word here. Anyone want to take a guess at what the key word is in this sentence? Simplify. That's a good one. Even more key than that. Units. Where did you see units in this question? So I'm looking at number one. Square root? No. There we go. Completely. That's why it's italic, so you know that it's important. We have to simplify the following square roots completely. Okay, let's take a look at what that means. If I have a square root fraction, like the root of 36 over 100, the first thing we want to do is think of it like two separate square roots. Good morning. Root 36 over root 100. Now, some of you can split this up in your head without writing it out, and that's fine. But we're going to have perfect squares here. What is the square root of 36? 6. What is the square root of 100? 10. That part's nice and easy, hopefully. You're not going to get a fraction that is not a perfect square. Okay? They're all going to be perfect squares. Now, is 6 over 10 simplified completely? No, it is not. That's why that's our key word here in this question. If you box up 6 over 10, you technically have not finished what you're being asked to do. Simplify completely. Good morning. So, if I want to simplify 6 over 10, how can I do that? Divide by 2. Good. Here's what that looks like. If we split these two terms up, what two numbers multiply to give me 6? 2 times 3. What about 10? 2 times 5. Is there any terms in common that we can cancel on the top and the bottom? Pair of 2's. And what are we left with? 3 over 5. There is our completely simplified answer. You're right. Good catch. We should have a plus or minus in front of that. Plus or minus 3 root 5. The only time we don't need a plus or minus is when we're talking about distance. Question? That'll be when we get to the second row. Hold that thought. We'll come up with that. We'll get to that. Does that make sense, how we split that up? How we simplified the fraction? That should be, 7th, 6th grade, even maybe 4th, 5th grade stuff, simplifying fractions. Give B a try on your own. Good. Everyone else, give B a try on your own. See if you can work through it, simplify the fraction completely. If you get done with B, give C a try. I'm going to leave A here so you can see what we did. Again, like I said, some of you may be like, oh, Mr. Church, this is easy. I get it. Fine. But you guys have self-identified on the survey yesterday. This is where you struggle. So that's why we're doing it. Nice. Good job. Yeah. Oh, did you? I don't give you this? My bad. Sorry, did I not give you this? Oh. Yeah, this is 65. Sorry. You did? Good. Plus or minus goes in the front. Oh, yeah. Yep. Good. You just said what goes into What'd you give us? Nice. Perfect. Yeah.
actually helped me do. That's good. 16? All right, thank you.
The square root of 36 is 6. The square root of 100 is 10. It's just our perfect squares. So what's the square root of 81? 9. And then what's the square root of 36? 6. Plus, so now just good, yeah. And then 6 is nice. What can we cancel out? Yep. And we'll have to what over what? There you go. Slap a plus or minus in front. And that's all it is. Yeah. You got it. It's a little bit more to break up on number C. Yes, great job. Yes, 6 times 2. Yes, and then 6 and 8, we can cancel something else out from that as well. Right? Maybe a 2.
Already crossed out the 2. Wait.
Another 2. Yeah, just like that.
Oh, right here.
Absolutely. Yeah. So good, you're halfway there, and this is what I was saying to Derek's. So you canceled out 2's, right? But 6 is 2 times 3, 8 is 2 times 4, and you cancel out another 2. What you did was you split it up differently and killed 2 birds with 1 stone by knocking out those 4's. Yeah, if you cancel out another 2 commodity pairs, you'll end up with Lillian's answer the same thing. Yeah. Yeah. And we'll get to that again. Stay with us. All right, let's take a look at B. B, what's the square root of 81?
9.
What's the square root of 36?
6.
Good. Go ahead and split up 9. How can we split up 9? 3 times 3. What about 6? 3 times 2. What can I cancel? Pair of 3's. What am I left with? Boom. Just like that. Plus or minus 3 over 2. As I was walking around, most of us had that, which is great. Part C, square root of 144. Square root of 256. 16. Okay. And we got to be more careful splitting this up. How can I split up 12? We could do 3 times 4. We could do 6 times 2. If I do 2 times 6, how can I split up 6?
3, 2.
2 times 3. So 12 is 2 times 2 times 3. Just like if we were doing a factor tree, we want to split it up all the way. How can I split up 16? 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Right? Is there any common factors we can cancel out on the top and bottom? Pair of 2's and another pair of 2's. Okay? What am I left with on the top? What am I left with on the bottom? 2 times 2, which gives me 4. Just like that. Okay? So don't forget your plus or minus signs. If we look down to D, what type of number is 25 in number D?
Negative.
Negative, sure, there's a negative sign. What type of number is 25 though? Starts with a P. It's rational. Proportional is close.
Perfect square.
Perfect square, right? 25 is a perfect square. What is the root of 25? 5. Now, do I want to have a plus or minus here? No. What do I want to have in front? Just a negative sign. Okay, this is the very beginning of the unit, so it makes sense if we forgot it by now. Well, it doesn't make sense. Hopefully we remember it, but I understand if we forgot it by now. When that negative sign is in front, we just have to make sure that our answer is negative. It is that simple. That's all we have to do. Okay, give E and F a try now. It shouldn't take very long, so 60 seconds max. They're both perfect squares. Good. Take a look at note sheet number 2 if you need help with those perfect squares. Nice. Yeah, it's not bad, right? we're starting out with the easy stuff. Getting it out of the way. Give number E a try. Or letter E a try. You know, zip.
I'm not gonna lie, I did not know what 16 was till I came to this.
Good. Wait.
I didn't even know what 13 was. I did not
So
know.
take a look. You split it up, which is great, but then the answer is just 5. And we want a negative sign in front instead of a plus or minus. So you're halfway there. You got the right roots. You got to write the final answer. That looks great. Yeah. No, that's what we're talking about next. Good. Oh, sorry, Tina. Perfect. Good. Yeah. We'll get there. I'm not going ahead. All right, what's the square root of 400? 20. So what's my answer?
Negative 20.
Negative 20. What's the square root of 169?
Negative 13.
Negative 13. That's right. The square root of 169 is 13. With that negative sign in front, my answer is negative. You're not going to get a negative imperfect square. So far, right, it's pretty simple because they're all perfect squares. Let's jump down to letter G, not number G, letter G. Because is 24 a perfect square? No. So what do we have to create here? A factor tree. A factor tree, right? So we just branch out from 24. 6 and 4 works for me. You could do 2 and 12. You could do 8 and 3. It does not matter. How can I split up 6? 3 and 2. How can I split up 4? 2 and 2. Everybody with me so far?
Yes.
Okay. I'm going to circle up all my prime factors. 3, 2, 2, 2. And I'm going to write them underneath my square root. We have not done anything right now but take apart 24 into its components. Right? If you've ever played with Legos, here's the finished set. We break it all down to its pieces. We still have the same number of things. We still have the same amount, right? Now, is there any pairs in this square root? That's what we're looking for. Pairs. Pair of 2s. What do I do with that pair of 2s?
Bring it out.
Bring it out. Okay. They fuse together and become a single 2. And that's all we can bring out of the square root. So what happens with these unmatched pairs that we have left over? We leave them in the square root and we multiply them.
And I'll give it 6.
2 root 6. There's our final answer. Except for the plus or minus in front. Can't forget about that. So someone asked, oh, would this one just be 12? No. Because it's not a perfect square, we have to break it up into its factors. We could technically do this same exact process above. 525. That's 5 times 5. Right? I've got a pair that I bring out to become a single 5. And this time I have nothing left over, so there's no square root. My answer would just be, and then we throw that negative sign, negative 5. So it's the same thing. It's just with perfect squares, when we identify them, we can do that shortcut. Okay? So follow what we did here in 24. See if you could break down 56. See if you could break down 120 and get a final answer there. Don't forget your plus or minus sign and your leftovers. Give those a try. I know some of you are ahead of me. That's fine. Those of you that are staying with me, give H and I a try. $56 would be 8 times 7. Close. You working on this? You will. I'm doing this for you guys. Well, is it even or odd? Even. Cut it in half. Divided by 2. See what you get. Yeah, so we can split up the 8.
Oh, yeah.
Good. Great job. Nice work, babies. Good job. What's up? I'll be right there. Don't forget about the 7. The 7 goes in here too. Right? It's a big number, but it's a prime factor still. Double check. What's that? Yes, that looks great. Yep, can't do anything with the 7. We leave that third 2 in there when we bring up the pair. Plus or minus 2 root 14 is perfect. So, yes, everything is great except for this very last step. We brought the 2's out, and left over we have a 2 times 7.
So it'll be 10 and
Right? Just like here we have 2 times 3 left over, giving us 6. 2 times 7 gives us 20. 14. Good. Nice. Good job. Give 120 a try. Give 120 a try too. If you don't know what 2 numbers multiply, cut it in half and see what you get. Nice. Good job. Good job. Good. Don't forget your plus or minuses. Those numbers are perfect. Good. Now for these ones, we don't need units because we're not talking about distance. We're just doing square roots. Yeah. So it's like pretty much with every answer, we either need a plus or minus or units, but never both. Because if we have units, then it's a distance and it can't be negative. You know what I'm saying? Like the side of a triangle can't be -6. Yeah. So it's either or, never both.
sure.
Good. Great job, Esther. What'd you get? Yes. So we've got a 3, a 2, a 2, a 5, and a 2. Write them all out and look for a pair. I would put them in,
Order.
I almost said alphabetical order, but you know what I mean.
Yeah.
Number order, I guess.
So I do 2, 3, 2, 2, 2. So 3, 2, 2, 5.
All those numbers on there, whatever the ends of your roots are, of your tree, or branches.
So the 2 goes over there.
There's 5 numbers.
Alright. Then the 3 stays.
Good. Yes, we bring the 2 out, we multiply the 3 times the 2, but we also got to multiply 3 times 2 times 5. See that little 5 left over too? So take that 6, multiply it by 5, that's what gets left over. So you brought out the 2's, good. What do you have left over that you can't bring out?
Oh.
You got a whole lot more than just the 2. All right, 56. Let's come together. A lot of this looks great. How can I break up 56? 7 and 8. Can I break up 7 at all? Can I break up 8 at all? Okay, what do I do? 4 and 2. How can I break up 4? 2 and 2. So again, I'm looking at all my end points of these branches. I'm not going to circle up the 4 because we turned it into a 2 times 2. I've got a 2 up here, and I cannot forget about that 7. I saw that a couple times as I was walking around. We can't forget that 7. It's a prime number as well. So I've got 2 times 2 times 2 times 7. Any pairs in there? Pair of 2's. Anything left over?
2 and 7.
What do I do with that 2 and 7? Multiply them. So the pair of 2's comes out in front. My remainder 2 times 7 gets multiplied together inside the square root. Plus or minus in front. There's our answer. Plus or minus 2 root 14. If I look at 120, what 2 numbers multiply to give me 120?
12 and 10.
12 and 10, you can do 2 and 60. You can do 3 and 40. You can do 4 and 30. Doesn't matter. 12 is 6 times 2. 10 is 2 times 5. 6 is 3 times 2. All right, I got a lot here. I want to keep track. I got a 3, a 2, a 2, a 2, and a 5. Okay. 2 times 2 times 2 times 3 times 5.
So you gotta take out the 2's,
I got a pair of 2's. I'm going to circle those up and bring them out.
then you keep that 2. The other's gonna
Okay, I keep this third 2 there. That's right. Can I bring out the 3?
be. You have to multiply 5 and 3 and give it 15.
Okay, good. We multiply the 3 times 5 and get 15. But then we also
Have a 2.
have a 2. So we're re-multiplying all these numbers together. What do we get when we do 2 times 3 times 5?
30.
30. So it seems like a large remainder, but there's no other pairs of factors. So plus or minus 2 root 30 is what we get. Did I lose anybody there in that one? So you got to bring out the 2's. You have left 3 times 5 times 2. Okay? Only the pairs can come out in front. Only pairs. Yeah, Ross. Yeah. Okay. Not too bad, hopefully. Breaking those down. Imperfect squares, irrational numbers. Okay. This next section is another area where you guys answered on the survey that you did not know how to answer it. I think there was 10 plus people that said they needed help with this. Okay. Now, the Ed puzzle, I know there was a lot of info. It was kind of confusing. Note sheet 7 and 6, a lot of info, kind of confusing. Here's a simple way for us to know. It's only going to be irrational when it is an imperfect square. Okay, so that's like everything we just talked about up above in GHI. All of these are irrational numbers. They're imperfect squares. A through F, these are all rational numbers because they are perfect squares. So irrational numbers are imperfect squares or ugly decimals. That's it. That's really all we need to know. If you have an irrational number, it's either an imperfect square or an ugly decimal. That's the key here. We don't have to worry about natural numbers and whole numbers and all that nonsense. Just irrational numbers, imperfect squares, and ugly decimals. So if I look at 2a, I have root 64. I'm going to ask myself, is that an imperfect square? What would your answer to that be? Is 64 a perfect square or an imperfect square? 64?
No.
Perfect. 64 is a perfect square. Right? So it's rational.
That's what we gotta write.
That's all you got to write. The square root of 64 is equal to plus or minus 8. 8's just a number. It's a whole number. It's an integer. It's a natural number. It's a rational number. It's a real number. It's all of the above. If I go to B, what's the square root of 144? 12. So my answer here is negative 12. Is that an ugly decimal number? No. So it's rational. Now, take a look at 2C. What do you see there in 2C? I see an ugly decimal. That is very ugly. There's no pattern here. 5628719 looks like a phone number. That's ugly. What can we call this number here? Irrational. It's that simple. Ugly decimal, irrational. All right? D. Now this is where people get thrown off. They see a fraction and think, oh, that must be irrational because it's a fraction. No, all fractions are rational. Remember, fraction, rational. Fractional, rational. I don't know. Think of it like that. Fractions, rational. Absolutely. The definition of a rational number is a number that can be written as a fraction, which means fractions are rational. Fractional, rational. Okay? Now, if I have the square root of 60, okay, is the square root of 60, is that a perfect square, 60? No, 64 is a perfect square. 60 is not a perfect square. So this one is irrational. We're just going to go through all of these because I want to make sure it's clear. Now look at F. What do you see in F?
It's an irrational number.
Now this is where we gotta be careful, okay? You look at that and you see the dot, 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 and you go, oh, that must be irrational. But this is not an ugly decimal. This is a pretty decimal. Because I've got 3.333333. Anyone want to take a guess at what the next four numbers in this decimal are going to be? 33333. If we can predict the pattern, it is rational. That's why I specify ugly decimals. If I have 5628719, predict what the next three numbers are going to be. You can't, right? It's just a bunch of random numbers. That is ugly. Yes, 4.44444, rational. 5.55555, rational. 6.38942106, irrational. Okay? What about G, 121? What can we call that? Rational. Duh, it's just a number. What about square root of 1? Rational. What's the square root of 1 equal to? 1. Duh, that's just a number. And what about I, 5.67? Think about it for a second. Rational. Rational. I could write this as a fraction, 5 and 67 over 100. I can't write C as a fraction. F, that's just 3 1/3. I can write that as a fraction. So this is not an ugly decimal. It doesn't go on forever and ever and ever with a bunch of random numbers. That is what we're looking for. Yeah. Hold on one second. So irrational, look for decimals that go on forever with no pattern and imperfect squares. That is all. Everything else that we're going to be talking about is rational. Darius, you have to go get water, right? Yeah. Okay, come on. When Darius comes back, you can go. This is not a huge part of the test, so if you're still confused on that, don't stress yourself out. Pythagorean theorem is more important. All right, word problems was another area where we struggled quite a bit. Can I get a volunteer to come up here and draw this diagram for me? Hope, come on up. We got a square box, 10 inches tall. Find the diagonal length. Oh, go for it. You just write right on it. Yeah. Just what does the diagram look like? Because it says we got to draw a diagram, label it, and then solve.
So just this one.
Yeah. Yeah, sure. Go ahead and set up the equation too. Good, perfect. I appreciate it. So, all we did was draw a square box that is 10 inches tall. If it's a square, then it's also 10 inches long. right? And the diagonal length, if we wanted to draw that, would be just like that. So that we have this triangle in here with a height of 10 and a base of 10. Great job. Good. So then Hope set it up. 10 squared plus 10 squared equals c squared. Obviously, this is my c. You can see she drew this little arrow coming from the right angle, so I know, all right, there's my c. Now that we have this set up, go ahead and see if you can solve it. It's not going to be a perfect square at the end, but do a factor tree and simplify as much as you can. What is 10 squared equal to?
100.
100. So we got 100 plus 100, right?
Yep. Yeah,
Let's see. 20 times 10. 10 is 2 times 5. 20 is 4 times 5. 2 times 2. 2, 2, 2, 5, 5. Then you do 2, 5, 5. Bring out the 5 and the 2 and multiply. Perfect. Yeah. All we're missing is the units.
Oh, unit.
Yes. What units are we using in that question? Yep. There you go.
Wait, hold on.
Now, be careful. We did 10 squared and got 100. 10 squared and got 100. We add those together and get a singular 2. Yes. Yeah. Then you take the square root up to 200 and break it down as much as you can.
25 times 2.
Nice. We need our units on here. The problem, what units are we talking about? We're talking about feet, we're talking about miles, inches.
Yeah, this is not.
Good,
It's not.
right.
so far so good. Very nice. Good. What are our units on this?
Really?
For those ones? So it'll be x equals plus or minus 13. B equals plus or minus.
Did you know we did?
Like that. If it's just like a random square root in the middle of nowhere, like this one, then it's just negative. So if we have a whole equation there, we gotta include all the equation, the letter basically.
Wait, give us a shirt.
Yeah.
So would it be 50?
Okay, what two numbers multiply to give me 200?
What?
201? Yes.
Oh,
We
I
gotta
thought
split
you
it up
said
more.
201 on the line.
If I have 200, right? How can I split it up? 100 times what?
2.
Okay. So 100 times 2, and then how can I split up 100?
10,
10 times 10.
Then I did.
5 and 2.
5 and 2, 5 and 2. Right?
Squaring on 1.
Yes, you can. 5.
5 can't be split? No. So we got 5 times 5 times 2 times 2 times 2. Don't erase anything, just write times 2 times 2 times 2.
So there would be both. So it would be both. What's that word?
Yeah, give it a try. All right, let's take a look. 10 squared is 100, plus 10 squared is 100. What's 100 plus 100? Anybody with me? 200. Is that my answer, 200? No, what do I have to do now?
Then you have to
Square root. Okay, we square root it, then we do the factor tree. What two numbers multiply to give me 200? 102. 2 and 100. How can I split up 100? 10 and 10. How can I split up 10? 5 and 2. 5 and 2. So now I have 5 times 2 times 5 times 2 times 2. Just like this. Okay. Is there any pairs I can circle up here? Pair of 2s and pair of 5s. Don't forget the pair of 5s. We bring those both out and multiply them. So what do we have in front now? 2 times 5?
2 times 4.
10. What do we have left over? A single 2. 10 root 2 what? Inches.
I did 2.
10 root 2 inches. Give me a thumbs up if that makes a little bit of sense, how we did that. Okay. Okay, maybe I didn't mention it, but the bathroom pass is over here now, so don't just leave without the bathroom pass. A couple people left without the bathroom pass. It's over here now, so you gotta come grab it before you go. All right? Okay, number 4 is the same exact thing, so give number 4 a try. On your own. Draw the diagram, label it, set it up, solve it out. Yeah. Actually, we gotta wait a minute. Just a minute. I'll let you know. I'll see you in like 2 minutes.
160.
40 times 40? Oh, yeah.
That's what you said.
Throw an extra 0 on there.
That's what I said.
40 squared? Yeah, 1600.
Yeah, I'm scared.
Give that a try, number 4. Yes. Did you notice the pattern between those last 2? Well, what's your answer here? 40 root 2 for a 40-inch tall square, right? What was your answer on number 3? 10 root 2 for a 10-inch tall square. Find a 30-inch tall square. What do you think my answer?
Wait, no.
Anytime you have a square, it's the side length.
I was tripping. I was doing my
If you look back on our
math.
old worksheets, I think it was worksheet 63 or something like that, 62 maybe. All the squares follow this exact same pattern. If I had a square that was 472 by 472, my diagonal is going to be
Yes,
472.
it was from over there. That's what it looked like. What?
Keep that in mind. Make it like
Bro, y'all gotta go.
You gotta go.
Yo. No way she's
So we're bringing it down.
You like to stream with those, so
Good.
instead of your work.
what it hurt. Alright, watch that.
So what I'm going to have to do,
1, 2, 3, 4.
look at that. 40 times 40 times 2.
Sour cream.
We got a pair of 40s.
Why are you doing chicken rolls? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
No? Okay. Let me show you. You get 3200? It's 1600 times 2. Times 40. Okay.
I know you just heard that.
40 is what?
No. You gotta go.
4 times. What is 4?
He's on Nigeria.
Okay.
See, for now, for the dollar call it candy cream, it shows your face, right?
Okay, so I've got 1, 2, 3, 4, 5, 6, 7 twos. 1, 2, 3, 4, 5, 6, 7 twos. What else do I have? 2 5s. Boom, boom. It's a lot. Okay? Is there any pairs in here? How many pairs of twos?
Oh, my PlayStation account. Oh,
We got 1 pair, 2 pair, 3 pair of twos, and then a pair of 5s. Right? What's left
I
over?
like to move it.
2. Okay, so I know it's going to end in root 2. That's my leftover. What is 2 times 2 times 2? Multiply it all together. Just equals what? 40. Okay. So we got 40 root 2. By doing all that work, breaking it all down.
Yes.
Pair of 40s, 2 left over.
Yeah. This one.
See what I mean? 40 times 2. Bring the 40s out, 2 left over. Way easier than doing all this. Because when we do all this,
Bro, they gotta
there's a
go.
chance we miss one of our 2s and we get something else. Anytime we do a square, right? We can stop right here at the purple pair of 40s. 2 left over. Right? What was the answer on number 3? Yeah, number 3 on purple. What was the answer?
I thought family, bro.
And our first square was 10 inches tall. And we had 10 root 2. Now we have 40 inches tall square. And we get 40 root 2. You see that pattern? Okay. All right, let's talk about this. We're running out of time. Kinda. So I got a 40-inch tall TV. It is a square. I'm gonna do 40 squared plus 40 squared equals C squared. 1600 plus 1600 equals C squared. 3200 equals C squared. Right? Square root both sides. 3200. Now remember, when we have a square, we can take a little bit of a shortcut. We just saw that 3200 is 1600 times 2. Right? And we just saw that 1600 is 40 times 40. Now, yes, I could keep going and split my 40s up into 8 times 5 and 8 into 4 times 2 and 4 into 2 times 2. That's the work you see up here on the right, over here in purple on the board. But that's a lot of work. That's a lot of 2s. That's a lot of 5s. I can stop right here because I have a pair of 40s and a 2 left over. 40 times 40 times 2. Group my 40s up and bring them out. 2 left over in the square root, inches on the end. All right? And that's what we get, 40 root 2. Any questions I can answer on those squares? What's that? No, definitely not. Definitely not. So what you did was you brought both 40s out and multiplied. If it's a pair, they fuse into one single 40. You don't look like you understand what I said. Ask your group. They'll be able to help. All right, this is where literally every single class I have, there was 20 plus people that didn't understand these. Okay? This class had 24 people who did not understand these. So if you understand them, great. Please stop talking so we can talk about this. Because I guarantee you, there's at least 2 people in your group that don't understand this. So if we need to find the length of the hypotenuse, and I'm looking at 5a, all right? Let me just, I'm going to do a blue side. I'll do a green side and a pink side. Which color side is my hypotenuse? Pink. So what letter can we call that hypotenuse? C. I'll call one of my legs B, one of my legs A. Again, we know that this is C because here's my right angle. It's pointing right at my hypotenuse. So if I want to find the length of my hypotenuse C, well, I need to know the length of my legs. Right? So if I'm looking at my blue side, side A, I don't see any numbers there. How can I figure out how long that leg is? Yes. Wait, you said finding the points of A and B? Yes, we're going to square them, we're going to add them, we're going to take the square root. How do I know what number to square? Saeed? Count the squares. Literally, that's all we have to do. Jackson, Ari? We just have to count the squares. If I want to know how long this leg is, lucky for us, it's on a graph. This blue leg is 1, 2, 3, 4, 5, 6, 7, 8 spaces long. Okay, I don't know how long is my green leg. 1, 2, 3, 4, 5, 6 spaces long. So that's all we have to do on these graphs is count how long the legs are to get those missing numbers. A squared plus B squared equals C squared. Is that making a little sense? Yeah? Question? Okay. When Delarian comes back, Delarian, go ahead. Yeah. So, what is 8 squared?
64.
Okay, what is 6 squared?
36.
Add them up and what do we get? 100. So if C squared equals 100, what do I do now?
You have to do a factor tree.
We don't have to do a factor tree here necessarily. What are we going to do on both sides? Square root. What type of number is 100? Perfect square. So when I take the square root of 100, what is C? 10.
Oh, okay.
Units. Because we're talking about distance. So this pink line here, C is 10 units long. Okay, give B and C a try on your own. Now that you know, oh, all I have to do is count, we should be able to get through that on our own. So give B and C a try. You might not get a perfect square, but that's okay. Just do what we did on the front.
And then it goes into 50 to group.
Good. So far, so good. Uh-oh. No, you did it right. We got 45. Well, so when we do the square root of 45, we're going to treat it like we treated each of these. Yes. Break it down. See what you get. Good. We got root 45. Then we got to do a factor tree and break it down.
Wait, you got 52 figures.
Let's say root 85.
Where'd you get 4?
Yeah.
Wait, did you do anything with the
Square root of 45 is nothing.
Oh, that's 3.
Square root of 45 is imperfect. We're going to do the factor tree, take something out, leave something back. Oh, right there.
45? Yeah, no.
No, I don't want to see any decimals. It should be something, root, something. It should be a pair that we take out. There should be a number that gets left behind. Do a factor tree. What's 2 numbers multiplied by 45? Perfect. Go from there. You got it. Yep. Nice. Yeah.
Oh, yeah, that's 45.
Yes, 45. So this side is 6. So you're counting wrong. How many boxes long is that line? You're counting the lines, not the boxes. 1 box, 2 box, 3 boxes. So 6 squared plus 3 squared
Yo. Oh.
Good. What did you get? Good. So we have the square root of 45. What did we do when we had the square root of 45? We did a factor check. Good job.
Okay, yeah, 45.
All right, let's come together. We'll talk about these. So B. 5B, how long is my first leg? 6. How long is my second leg? 3. I'm going to do 6 squared plus 3 squared equals C squared. 6 squared is 36. 3 squared is 9. Add those together and I get 45.
Wait, you can do something before you.
Okay, good. Give me 1 second. Go ahead. So I've got 45 equals C squared. I'd appreciate you guys staying with me. I know this is going long, but it's important. What do I do on both sides now?
Square root.
Square root. Is 45 a perfect square? No. 49 would be a perfect square, but 45 is not. So, anytime we take the square root of an imperfect square, we have to do a factor tree. What two numbers multiply to give me 45? 9 and 5. What two numbers multiply to give me 9? 3 and 3. I've got a 3, and a 5. All right? 3 times 3 times 5. Is there any pairs I can bring out? Pair of 3s comes out. What's my leftover? 5 is left inside the square root. 3 root 5 units.
Yo.
How long are my legs on C? 5 by 5. Is 50 a perfect square?
Yeah.
No.
5 and 10. What about 10? 5 and 2. I got a pair of 5s and a 2 left over. Pair of 5 comes out in front. Single 2 left behind. 5 root 2 units is what we get there. Anybody get those two right on their own, B and C? Good. If you did, you're in great shape for the test. Last but not least, almost done. Ladder problems. Not too bad. Right away, I see I'm talking about a ladder. I'm going to draw my picture. I'm going to draw a little building. I'm going to draw a ladder going to the top of it. And I'm going to draw the space in between those two things. Okay. There's my drawing. In this drawing, I have three measurements: the height of the building, the length of the ladder, and the distance between the base of the ladder and the base of the building. Do I know how tall the building is from this problem?
Yeah.
How tall is the building? 8 feet. It says so.
The base of
The base of
8 feet.
an 8-foot tall shed. That's a typo. That's my bad. Do we know how long the ladder is?
6 feet.
Read it again.
The base of the ladder.
No.
We do not know how long the ladder is. That is what the question is asking. So what else do we know in this problem?
The base of the ladder is 6 feet.
How far away the bases are. The base of the ladder is 6 feet from the base of the shed. Here's the base of the shed. Here's the base of the ladder. 6 feet. So I know the height of the shed. I know how far away they are. What variable am I solving for here? C. 8 squared plus 6 squared equals C squared. See if you could solve that out on your own and figure out how long the ladder is. Perfect. We're on number 6. So go ahead and write number 6. Do the little drawing. Good. And don't forget your units on the end. We're talking about a word problem. We need our units on the end. So we got units, but what are the units in this problem? We've got to be specific. Good. What are the units in the problem? Be specific. 50 times 50 is 2,500. Yes, you are. Good. Take it away. So, if we're just talking about a generic thing, we use units. What are the units in this problem? Feet. Units is just our generic fallback. If I don't know if I'm talking about feet or inches, I use units. If I do know, I have to be specific. So we brought out a pair of 5s and a pair of 2s. Why is the 2 still left over? If we brought them both out, then we multiply them together. And there's nothing left over. See what I'm saying? That's right. I got you. I still want to say. Yes. So this one we know the ladder. We don't know how far the grade
We
7.
have science next.
Yeah. Yes, exactly. All right, 8 squared gives me 64. 6 squared gives me what? 36. Add them together, what do I get? What do I do now? Square root both sides, thank you. What do I know about 100? It is a perfect square. There's a reason we run those blockets. We skipped what? Okay. Square root of 100 is 10. Feet. We're talking about feet. We got to use the units that are in our problem. You can put C equals 10 feet. You could write out the ladder is 10 feet. It doesn't matter. Either one works. Okay. Now the setup in number 7 is a little bit different. We're not going to have time to go through it. But if we're setting it up, it's the same drawing. The base of a 10-foot tall shed. Okay, the shed's 10 feet tall. has a ladder leaning against it. Now we know that the ladder is 20 feet long. What we want to find is how far away the base of the shed is from the base of the ladder. So there's the setup. You can finish that on your own. And we'll turn this in tomorrow because I want you to finish this. Thank you. Yes.